Hello, ladies, and welcome in to class today. Yeah, this is class, unfortunately. So I am on my way to Kansas City right now. Not like right now when I'm recording it, but right now when you're watching this, okay? So that's why we're not doing a Zoom, okay? So what I'm going to do is I'm going to go through the math part of this chapter, and then I will make the test available for you. I'll also post the answers to your chapter review, and you'll be able to go ahead and finish this chapter, and then tomorrow you will be able to start the next chapter. All right, so let's look down here at the screen, and we are on page 326. Page 326, okay? So if you will go ahead and open up your book there, you will need that. We'll kind of jump around just a little bit, but what I'm going to try to do is teach you the math section, kind of the math section of this chapter, so that you don't have any other questions, and then you can take your test. All right, so the example there on page 326 says we have HCl and RbOH. All right, so that's what we're dealing with. Remember, we're dealing with acids and bases. That's been the kind of the story of this chapter. And a couple things that I want you to a couple notes to make in your minds right here. This is the first note that I want you to write down in your notebook. Most bases are OH negative. That's going to be very important. This is super important to remember. Almost all bases are OH negative. There's only one exception, really, and that's NH3 is the exception. Okay, so when you get the NH3, that's a base, but it is not OH negative. So most of the time when we're dealing with these, we are dealing with OH negative. Very important, and we'll talk about why in just a second. The other thing that I want you to write down in your book is this right here. And technically you do need that H under there. So an acid plus a base, a hydrogen base, all right, is always equal to salt plus water. Okay, what does that mean? So this is going to be, water is always, H2O, right? There's always hydrogen and oxygen over there. But the salt can be different. There can be different types of salt. Table salt is different than sea salt, and sea salt is different than... There's all kinds of different salts, trust me. Now, all salts are going to have some sort of sodium, chloride, something like that with it. So all salts are going to have either a sodium or a chloride. They have to, okay? So when we have this, we have... basically over here, we know that this is going to be a Cl or an Na. And we don't know exactly which one it's going to be. This salt is kind of the mystery that we're solving in these questions. Okay, so if you look down at this, you can kind of figure out pretty fast that it's going to have a Cl in this one, right? Because there's a Cl in that. So basically here, we're going to end up with water. Okay, so we're going to end up with a salt, so we're going to end up with Cl something, or something Cl, plus, and we're going to have H2O over here. Okay, it's going to come out to water. So now, the question is, if you look over on page 327, how did we get to that? Well, remember, if we go back up here, most bases are OH negative. So if you take this OH and it's negative, that means that this Rb is going to be positive, okay? Then you have to remember that the H is always going to be negative, and so that makes the Cl positive. So the Cl and the Rb go together, so ClRb. And then there's our H2, and then here's our O2, and here's our H2. So there's two hydrogens, one oxygen. So there's our H2O left over. All right, so we have to take this right here, and this is our salt. Now, I wrote it backwards, so it would be RbCl plus our H2O. All right, and that would be our answer. So that's kind of how you go through that, and I'll let you kind of work through the rest of it. but the positives would go together and then the negatives would go together in your solution, just because of the way that the salts and the acids are set up. The negatives, see over here, it's the positive and the negative together, right? So they're stable in this form. In this case, the waters are negative and the salts are going to be positive, and they're going to, they're going to join together. Yeah, there's a lot you can read about it. I won't take the time to go through it all, but there's a reason why those positives can stick together, because they're in this acid, base, salt, water compound formula coming together. They stick together even though they're both positive. Okay? All right, then the next problem on page 329, let me write that, page 329. Go ahead and skip over there. Notice in the blue letters right above, on page 329, right above the example, it says in blue, covalent bases accept only positive H, one positive H ion. Diproctic and triproctic acids require more than one covalent base to accept their positive H ions. All right, so because of that, all we're going to be doing on this one, all right, is we are taking an H basically away from the other one. So let me write this down. So we have the H3PO4 plus the NH3 is going to yield what? So basically what's going to happen in this one, because this is triproctic, what's going to happen is that means it wants to send 3. Okay? Why is it 3? Because there's a 3, right? So it wants to send 3. It can send 1, but it wants to send 3 because there's 3 of these. So basically what ends up happening is these 3 jump over here, so you end up with 3 of these, and then you have NH3 and then PO4 plus PO4, and that's that right there. All right, a little bit confusing there, but that's what happens. You can read about it. And then the next reaction is between the H2Cr2O7 and water, and you can look at how that one works. Basically, you have to look at, again, these words, these vocabulary words that you've been learning are important. What does diproctic mean? It means it wants to donate 2. What does tri means? It wants to donate 3. So depending on what you start with, that's kind of going to tell you how many are going to go over to the other side. Hopefully that makes sense to you. Make sure that you look through the book and read through that. All right, next on page 331, page 331, we are going to take this question and we're going to figure out what's the molarity of this. Okay, so the question is saying, what is the concentration in units of molarity of NaOH if there is 2.6 moles of the substance in a solution with the volume of 534 milliliters? The first thing that we want to do is we want to convert it to liters from milliliters. So if you have 534 milliliters, the way that the book does it, I mean, I have several different ways to do this. I just move the decimal. The book shows you cross multiplication and all that. All you need to do is say, okay, milliliters is 1,000. There's 1,000 milliliters. So I'm going to move my decimal 3 places. So basically, I'm going to go from the decimal point being here, 1, 2, 3. So now I have 0.534 milliliters. And the book does it in a different way. I'm just showing you a little bit of a shortcut. If you want to do it the way the book shows you, fine. I just like to move decimal points. If you want to go ahead and divide it all out, that's fine with me. The next thing, we need to take the number of moles. So number of moles over the number of liters. Okay? And so the number of moles in this, the question says, what are 2.6 moles? 2.6 moles over how many liters? Well, the question says that it was 534 milliliters, but we're going to do, we converted it to liters. So 0.534 4.534 liters. Now all we have to do is just do this division problem right here. All right, so here's my calculator, and I just want to do this division problem. So I'm going to do 2.6 moles, and that's going to be divided by 0.534 liters, and that's going to give us 4.87. We're going to go to 3 decimal places because this goes to 3 decimal places. So we need 3 significant digits. So yeah, 4.87. 4.87, and that would be, the question wants to know how many moles, so that would be in moles, 4.87. The book rounds it to 4.9. I would probably put that in 3 digits because it gave us 3 here, but the book gives it to you in 2, so we'll go with 4.9 moles. That's a pretty easy question right there. So you just have to convert and then divide. Bingo, you're done. All right, the next question is on page, let me write it down so you have it, page 333. All right, so we're going to do example 9.5, and what it wants is we're going to make a dilution now. So we're going to dilute something, basically water it down. And so what we're doing is we're diluting 12 moles of HCl, hydrogen chloride, to 500 milliliters of a 3.5 mole hydrogen chloride. So we're diluting it, we're watering it down. Okay, you do this a lot with like household cleaners. So basically, if you know it comes in and it says, okay, this is concentrated, so before you use it, you have to add water to it. Okay, so this is happening in real life a lot of times in your kitchen as you're cleaning different places. This happens in recipes, all kinds of different places. So here we go. So we need to know it's called the molar dilution equation. Okay, so that is on page 332. So just look back across the page, 332, and you'll see that. So what we're going to do is we're going to take this dude and we are going to plug it into this formula. What is it? M mole 1 volume 1 equals mole 2 volume 2. Okay, and so now we're just going to plug in, and then we're going to find kind of the missing link to what we need. All right, so mole 1, that's this guy right here. So that's going to be 12.0 times volume 1. What is volume 1? That's what we don't know. So times volume 1 equals volume 2, and I should put moles next to this, okay? And let me put this in parentheses so you can see it, okay? And then over here, the other side is mole 2, which is mole 2. This is the mole 2. So 3.5 moles, we'll put that in parentheses, because this is an algebraic equation that we're building, times volume 2. What's volume 2? This guy right here, 500.0 milliliters. Okay, now all we want to do is we want to go ahead and we want to solve this. We want to work this out. Well, if this is our variable, let's say that this is now our x basically. So we want to divide this side by 12.0 moles, and we want to divide this side by 12.0 moles. Okay, when we do that, we get a cancel, and so we get that this, I'll just erase it rather than to write it again. All right, so we get that this this volume 1, that's what we're looking for, equals this right here. All we need to do now is plug that into our calculator. We need to do this 3.5 times 500 divided by 12 moles. So notice we're going to cancel the moles. So we'll do the 3.5, and we're going to multiply that times the 500, and then we're going to divide it by 12. Divided by 12, and that's going to equal 145.83. 145.83. And notice we're in milliliters still. So that's going to be our answer. Now, you could round that off if you want to. I think the book rounds it off to 1/5, and then the book does it in scientific notation. So basically, they move the decimal here, 1.5 times 10 to the how many decimal spots? 1, 2 times 10 to the second. There we go. That would be your answer, and that's in milliliters. So, these are basically the same answers. This is more in scientific notation. This would be more in mathematical notation. So just remember how to convert to scientific notation, how to round off, and do all that good stuff that you need. So there's another example of basically the same thing, but that's the technique that you would use. How are you going to solve that? Well, this is the only thing that you can solve it with right there. Okay, so M1 mole 1 times volume 1 equals mole 2 times volume 2. Set it up into an equation, move it over to the other side, do the division, whatever you need to do. Boom, it's going to kick you out an answer. There is one more example, 9.6. I won't take the time to go through that one. Make you work for it just a little bit. So I want you to go through that one. I want you to think through it using the different things, the techniques that we've already used, kind of that cross multiplication, kind of moving things just like we did. It's almost like this last one's almost a combination of all of them. So we're going through back to this first one that we did where OH negative, and we move it to the other side and we combine them. You always get the acid plus the base, gives you salt plus water. All right, so you work that out basically kind of like this one on page 329, where sometimes they can be tri or di, 1 or 2 or 3 you want to move over, whatever you start with. You're putting all these things together, and then going from moles to milliliters and the conversion, the one that we just did, put it all together, all those different concepts kind of, and then you're going to solve the one that's on 9.6. All right. Hopefully, if you missed anything there, just go ahead and rewind it, watch it again, slow it down, take notes on that. And then I am going to drop in this lesson, I'm going to drop your answers to your review for your chapter. And then I'm also going to go ahead and put your test in so you can get that done. All right. Have a good one. We'll see you later. Bye-bye.